Take a look at this chart plotting the projected population of emperor penguins from 2022 to the year 2100. Under current high-emission models, it shows a steep, devastating crash. By the end of the century, 90% of colonies could face quasi-extinction. To understand why the world's largest penguin is facing such a sharp decline, we have to look at how they've adapted. Emperor penguins are built for the absolute coldest environments on Earth, surviving temperatures that plunge to -50 degrees Celsius. Their most unique biological trait is how they raise their young. They completely abandon solid land. Instead, they breed, incubate, and rear their chicks entirely on the frozen surface of the ocean. Specifically, they rely on a foundation called fast ice. This is sea ice that is physically locked, or fastened, to the continental coastline or the seafloor, rather than freely floating in the open water. Raising chicks over the ocean is an extreme biological gamble. This frozen sheet offers a perfect flat nursery, but one that is entirely temporary and prone to vanishing. As a breeding ground, fast ice offers 3 crucial advantages. First, it provides a highly stable surface for keeping eggs safe. Second, it forms a thick barrier that blocks deep water predators, like leopard seals, from reaching colonies. And third, it places the penguins right on the border of rich hunting grounds. The catch is the timing. To successfully raise a single chick, this frozen platform has to hold together for almost an entire year, while the penguins complete a massive, grueling biological schedule. The consequences are absolute. If this ice platform breaks apart prematurely, the chicks fall into the water, and the entire colony perishes. The survival of the emperor penguin depends entirely on sea ice, following an ancient, predictable calendar. This biological clock starts in autumn. Adult penguins complete a punishing march of up to 120 kilometers away from the open sea, traveling deep onto the fast ice to establish their breeding grounds. Once the female lays a single egg, she returns to the sea to hunt. The male then takes over for an extreme winter endurance test. He carefully balances the egg on his feet to keep it off the ice, surviving a continuous 115-day fasting period. To survive the brutal winter winds, thousands of male penguins stand shoulder to shoulder in a massive huddle. They slowly rotate from the cold edges to the protected center, sharing body heat and raising the core temperature of the group to a balmy 24 degrees Celsius. When spring arrives and the chicks finally hatch, they are covered in a soft layer of gray down. These early feathers keep them warm in the frigid air, but they provide zero waterproofing against the freezing ocean. Finally, during the summer, the adult penguins go through a molting phase. They shed their old waterproof feathers and grow new ones, leaving them completely unable to swim for weeks. Every single stage of this endurance test, from the 115-day incubation to the summer molt, requires the ground beneath their feet to remain completely solid. That solid ground is now fracturing. Warming temperatures are causing the fast ice to thin, and it is cracking apart earlier than scheduled.
The immediate result is devastating. Because the ice breaks up early, young chicks are plunged directly into the ocean before their waterproof adult feathers have fully grown in. Without that protection, they quickly die of hypothermia. We are already seeing this happen on a massive scale. Recently, in the Bellingshausen Sea, the fast ice melted so early that 4 out of 5 emperor penguin colonies lost 100% of their chicks in a single season. The adults face a secondary trap. Moulting penguins wasting on the ice are suddenly forced into the freezing water without their protective feathers, severely dropping their survival rates. Climate change is destroying the precise, synchronized timing that allows the species to exist. There is also a hidden ecological threat lurking beneath the surface. The bottom of the fast ice acts as a biological ceiling where phytoplankton, microscopic plants that anchor the entire Antarctic food web, grow and thrive. When the fast ice disappears, the phytoplankton go with it. This causes a direct crash in the populations of krill, the tiny crustaceans that serve as the primary food source for the penguins. The accelerated melting of the ice creates a deadly dual threat. It physically shatters their coastal nurseries, while simultaneously starving the birds that manage to survive. The impact of these compounding threats is measurable. Between 2009 and 2018, the global population dropped by 10%, wiping out approximately 20,000 adult penguins. Tracking this decline across the vast, hostile Antarctic landscape is incredibly difficult. Scientists have to monitor the birds from space, using satellite imagery to locate remote, undocumented colonies. Because penguins are too small to count from orbit, scientists look for indirect evidence. They scan the white landscape for massive swaths of reddish-brown guano staining the ice. By calculating the size of these stains, researchers accurately estimate population sizes. This data is then used to establish marine protected areas that secure vital krill populations, and to track and limit black carbon soot from shipping vessels, a pollutant that darkens the ice and causes it to melt faster. The statistics are undeniably grim, but these modern monitoring tools give conservationists an exact data-driven roadmap for where and how to protect the most vulnerable colonies. The lifespan of the Antarctic fast ice is directly dictated by global carbon emissions. The choices made thousands of miles away determine how long that frozen platform holds together. This means everyday actions play a role in their survival. Reducing home energy consumption, minimizing fossil-fueled transit, and supporting clean energy policies all pull carbon out of the equation. These local actions have a measurable impact on slowing the rate of global warming and preserving the structural integrity of the polar ice caps. Saving the emperor penguin relies on our collective ability to reduce emissions and keep their frozen foundation intact. Every fraction of a degree buys them vital time.